anybody response there? Yeah, is it audible, Kushal Jain? Am I audible to you? Yeah, thank you. Hello, dear students. Welcome to the class. I'm sorry for the delay. There was a small glitch in the network. Now is it okay, AK? Now is my sound is fine? Check it, check it. Is it okay official now? AK official, is it okay now? Can you check now? Is my sound is audible? Monica? Yes sir, but little bit more if possible. Okay. Now is it okay? Is it okay now? Check it. AK official, can you check it now? Please tell me. Is it fine? Check it. AK official, can you check it now? Please tell me. Is it fine? Now it's okay, official? Yes sir, fine. Chalo. Welcome to the class. Welcome to everyone. So this is Satishkumar Durishetti. I'm the faculty of instrumentation. Okay. So faculty of instrumentation for the field of GATE and ESE. So overall teaching experience, I have 13 years of teaching experience in the field of GATE and ESE. I'm ex-faculty of ACE Engineering Academy. The subjects I handle are sensors and industrial instrumentation, optical instrumentation, process control instrumentations, measurements, microprocessors, and mechatronics also. Recently we have started the mechatronics subject also for mechanical people. So as you are aware of that, for instrumentation students, we are having 3 subjects. One is the sensors and industrial instrumentation. This is one subject. Second one is optical instrumentation. Third one is process control instrumentation. So these are the 3 subjects. No sir, again same problem. Not audible. Now check it. Voice is able to hear. Romario, is it fine or not? Romario? check now. Is it audible now? Now can you check it? Now can you check it? Is it fine? Now can you check it? Now can you check it? Is it fine? Can anyone respond about my voice? Sir, Sai Pavan. Is it okay now? Now it's fine, sir. Okay. Something that is a problem with the settings, sir. Okay. Yeah, Pavan. Thank you. Thank you. Now listen carefully. Yeah, listen carefully. Yeah. If anyone is facing the problem, please respond me. Can all of you show me the thumbs up? If it is fine, can you show me the symbol? If it's fine, can you show me the symbol? Fine, sir. It's good now. Okay, thank you. Thank you. So this some initial settings have to be done in the system. So next time onwards, it won't be repeated. So these are the three subjects related to instrumentation. One is the sensors and industrial instrumentation. Second one is the optical instrumentation. Third one is the process control instrumentation, dear students. Sensors and industrial instrumentation, optical instrumentation, process control instrumentation. You know, I think very well, in our BTech we will study them as transducers. Yes or not? Transducers. Yeah. Optical instrumentation is all about light. They will study in BTech as OELI, optoelectronics and laser instrumentation. And process control instrumentation they will study as PCI, process control instrumentation, PCI. So these are some standard subjects. Okay, now, chalo, coming to the weightage of this subject, today I am going to discuss about sensors and industrial instrumentation. So today's discussion is all about sensors and IA. Today's discussion is all about sensors and industrial instrumentation. Okay, so as you're aware of that, in our BTech, in the GATE exam, the weightage of sensors and industrial instrumentation is around 7 questions. That means around some are 2 marks questions, some are 1 mark questions. So it's the last. So on an average, we can expect 10 to 15 marks. 10 to 15 marks we can expect a minimum from our subject, sensors and industrial instrumentation. Is it fine? So listen students, it is not only for GATE, as well as we have to think about BARC, DRDL also. For other exams also, other industrial exams also we have to focus on it. Other industrial exams also we have to focus on it. Okay, do you understand this point? So GATE, BARC, DRDL and other exams also. Okay, and even you go for private sector jobs like Reliance, oil industries, paper industries. So for all those things also, you need to focus on the subject sensors and industrial instrumentation. So let us start the questions now. Today's question, we will start today the questions on temperature. Today's discussion is all about temperature. So you know very well, actually, under the temperature, majorly we have 3 transducers. One is the RTD, second one is the Thermistor, yes or not? Thermocouple. I think all of you know RTD, thermistor, both are resistive type or what type? Can anybody respond there? Sai Pavan, can anybody respond there? RTD and thermistor are resistive type or inductive type? RTD stands for. Can anyone respond? RTD and thermistor is suitable for what? RTD, resistance temperature detector or not? It is resistive type or not? Yes, it is a resistive type. This is also resistive type. Yes or not, Romario? But thermocouple is what? Thermocouple is an active type of transducer. Thermocouple is an active type of transducer. Is it clear? Thermocouple is an active type. Why? Because thermocouple converts temperature to EMF. But in the process of conversion of this, there is no external supply voltage is required now. No supply is required. That's why they are called active transducers. Yes or not? So this is passive. RTD and thermistor is passive and thermocouple is active. Chalo, now we'll start with our discussion this point. A thermistor has a resistance of 1 kilo ohm at temperature 298 Kelvin and 465 ohms at temperature 316 Kelvins. The temperature sensitivity in Kelvin inverse, where R is the resistance of the temperature of the thermistor at 316 Kelvin is dash. How to solve this problem? Can anybody respond? Dear students, if you see this problem, a thermistor has a resistance of 1 kilo ohm at temperature 298 Kelvin and 465 ohms at temperature 316 Kelvin. Dear students, listen. Thermistor means what? Thermistor is defined as thermal resistor or not? Thermal resistor. As the temperature increases, resistance decreases or not? Thermistor follows negative TCR characteristics. That means as the temperature increases, resistance decreases exponentially. So this is the initial temperature T0, this is the initial resistance R0, this is the final temperature T, so this is the final resistance RT. Yes or no? So as a characteristics, as a graph is exponentially changing, the characteristics equation is also exponential. The characteristic equation is given by RT is equal to R0 into exponential of beta into 1 by T minus 1 by T0. Am I right or not? 1 by T minus 1 by T0. So from this I can write RT by R0 is equal to exponential beta 1 by T minus 1 by T0. So this can be converted. So in this question, what is asking? In this question, what is asking? The thermistor has a resistance of 1 kilo ohm. Thermistor has a resistance of 1 kilo ohm at temperature 298 Kelvin. Yes or not? So let us take 298 Kelvin. At 298 Kelvin, it is having 1 kilo ohm. And 465 ohms at temperature of 316 Kelvin. At a temperature of 316 Kelvin, it is having a resistance of 465 ohms. All of you following? Can anyone respond? Can you show me your response? Please respond in the middle so that I can understand you. All of you are live. It's AK official. Are you respond? Sai Pavan, are you there? Man vlog. Satish. Monica. Sushmita Kumari. Hi Sushmita Kumari. Sure. So this can be taken as T0. This can be taken as T0. This can be taken as a T. This can be taken as R0. This can be taken as RT. So what is asking? The temperature sensitivity in Kelvin inverse. What is this? What is this temperature sensitivity in Kelvin inverse? The temperature sensitivity in Kelvin inverse is nothing but the alpha. So alpha का formula है minus beta by t square. Yes or not? Hi Sushmita Kumari, welcome. So beta is our doping constant. Beta is our doping constant. Why? Because thermistors are manufactured by which materials? Thermistors are manufactured by which materials? Semiconductors now. So semiconductors are having negative, semiconductors having doping also now. Semiconductors are also having doping. So alpha is equal to minus beta by t square. Am I right or not? So the units are minus per Kelvin. Minus per Kelvin. Yes or not? Because beta is in Kelvin. Beta is generally material doping constant. Depends upon doping. Depends upon material doping. Okay. So now the question here is, what is asking? So from the data, first of all, we have to calculate the beta value. Am I right? So if you calculate the beta value, how to calculate the beta value? We can use that equation ln RT by R naught is equal to beta into 1 by T minus 1 by T naught R naught. So if you substitute all these values, RT is equal to 465, R naught is equal to 1000 ohms. So beta we don't know. 1 by T is 316 Kelvin. T naught 298 Kelvin. If you solve this, you will get the beta value. Okay. Once the beta value is known, what is asking? Once the beta value is known, what is asking? Where is asking alpha value. Is asking the temperature sensitivity in Kelvin inverse. So at 316 Kelvin temperature, that means what? So yeah, here. Once the beta is known from that method, and if you're following or not, once the beta is known from method, if you substitute the 316 Kelvin whole square, you will get the alpha value. Hi Sushmita. So finally, alpha value will getting us minus 0.04 per Kelvin. You can check the answers. So this is going to be the answer. All of you followed? Can you show me the thumbs? Yeah. So that is about alpha value. Any doubts you can post there. Any doubts you can post there. Sushmita, Romario, it's AK official Sai Pavan. If you're having any doubts, you can post there. Next question. Next question. This is a very important question. If you see this question is related to control systems. So this is a combination of controls and instrumentation, both. So in this question, what are you asking? The characteristics of a thermometer measuring ambient temperature is given by this expression. 2 dTi by dt plus Ti minus Ta is equal to 0, where Ti and Ta are the indicated and ambient temperatures respectively. Dear students, question is asking about control system. If you check, he is asking the minus 3 dB cutoff frequency in the frequency. Very good question. Question asked in GATE 2011. So we know everybody have, as we know that thermometer or thermistor or RTD or thermocouple, whatever it may be, it is a system. So if you take a system, yeah, this is a system. So thermometer is a system. Ambient temperature is the input. Indicated temperature is the output. So he has given the time domain equation. The time domain equation is given as 2 dTi by dt. 2 into dTi by dt plus Ti minus Ta is equal to 0. So if you apply the Laplace transform to it, you will get 2 into S into Ti of S plus Ti of S is equal to Ta of S. So now if I take Ti of S common, that will be 1 plus 2S is equal to Ta of S. So the transfer function of the system is Ti of S by Ta of S. So Ti of S by Ta of S will be 1 by 1 plus 2S. Yes or not? So this is the transfer function. All of you are following? Sai Pavan following? Yeah. So this is our transfer function. So if you see this transfer function, so Ti of S by Ta of S is equal to 1 by 1 plus tau S. S is equal to j omega. 1 by 1 plus S is equal to j omega 2 omega. So the magnitude is equal to Ti by Ta is equal to 1 by 1 plus 4 omega square. So 1 by 1 plus 4, that is 2 pi f whole square. Suppose if you take frequency, this is the frequency of input temperature, ambient temperature is equal to 0, then the magnitude is equal to 1. Suppose the frequency of ambient temperature is infinite, then the magnitude will be what? 0. That means for static inputs, the response is good. For dynamic inputs, the response is poor. Now if you draw the plot, so this is the frequency and this is the magnitude. At frequency 0 and frequency infinite. So this is the magnitude. Okay, now? So this is the magnitude. All of understood? So if you check this magnitude, yes or no? Please respond here. Please respond. At 0 frequency, the response is 1. Am I right? This is 1. As the frequency goes on increasing, the response decays. So he's asking the minus 3 dB frequency. In analog, you could have studied. Minus 3 dB frequency means what? It is a cutoff frequency. What is this frequency? It is what we call cutoff frequency. So this is our cutoff frequency. So at this particular cutoff frequency, we know very well, in analog you could have studied, it becomes 1 by root 2 na? Exponentially, yes or not? Do you understanding or not? Cutoff frequency, it's a low pass filter characteristics or not? For a low pass filter, cutoff frequency is nothing but corner frequency. At corner frequency, the gain becomes 1 by root 2. So he's asking that only. Minus 3 dB frequency means cutoff frequency. So m is equal to 1 by, I'm sorry, this one is square root should be there na? Root over a square plus b square. Square root should be there or not? Yeah. So m by square root of 1 plus 4 omega square, 2 pi f whole square. At f is equal to fc, this m becomes 1 by root 2. So if you solve this, fc we are going to get as 1 by 4 pi hertz. That means the cutoff frequency is coming as 1 by 4 pi hertz. So if you check this 1 by 4 pi hertz, that is 4 into 3, approximately 4 into 3.4, and it is coming 1 by 12. 1 by 12 means 0.1. Even not even less than, it is even less than 1 hertz. Yes or not? Less than 1 hertz means what? It is not even 1 cycle per second. That means the temperature is almost static or not? So from the frequency response analysis, what do you understand? From the frequency response analysis of the thermometer, it can be understood that, it can be concluded that its dynamic characteristics are similar to that of low pass filter. Am I right or not? That means thermometer is best suitable for static temperature measurement or not? Yes or not, Sushma? Followed or not? It's a good question or not? Can you respond? So that means he is testing the control system knowledge. He's testing the controls knowledge is important. Controls is important. Can anybody respond there? Anybody can respond there? Yeah, control system subject is also important. So from the controls we got this problem. Next, another question related to controls. Yeah. How to solve this question? A thermocouple is suddenly immersed in a medium of high temperature. The approximate time taken by the thermocouple to reach 98% of the steady state value. That means, so this is the response. So it won't reach immediately, right? It won't reach immediately, slowly it reaches. So question asked is, what is the time taken? Is asking the time taken to reach how much? 98%. I think all of you know, thermocouple is a first order system or not? Yes or not? Thermocouple is a first order system or not? So for first order system, we can take the transfer function. The transfer function of the first order is equal to k by 1 plus 2s na? K by 1 plus 2s or not? Yeah. So if you take the inverse, if you take some s common, if I take tau common, it becomes k by tau. So if I take common, it becomes s plus 1 by tau. Yes or not? So if you take the transfer function, it becomes e power minus t by tau. Yeah. At what value of time it will be equal? So we know very well, when t is equal to 4 times of the tau for a first order system, the magnitude will become almost 1 na? Yes or not? So the correct answer will be option C. Option C. Equal to 4 times of the value of the time constant. At t is equal to 4 tau, this equation becomes equal to the maximum. Thermocouple is treated as first order system. So first order system, if you derive the time domain equation, yes or no? Yeah. Clear all of you? All of you following or not? See, I'm watching your YouTube comments. Based on that, I am going for the next problem. So please regularly you please type there so that I can understand you're following or not. Sushmita, following or not? For first order system, a t is equal to 4 tau. Yeah. Listen carefully. First order system conclusions. First order system. At a t is equal to tau, the output is 63.2%. At a t is equal to 4 tau, the output is 98%. Got it or not? So very good. Thank you. Thank you very much. So next problem, this one. For a copper constant and thermocouple. So he has given a question. Again, this is on the sensitivity concept. So thermocouple converts temperature. Yeah, for a copper constant and thermocouple is a T-type thermocouple. The junction potential E at theta degree Celsius is given by one equation. So this is the E. So this is the temperature difference, actually delta T. I think all of you know. Sushmita, all of you know. Thermocouple converts temperature to voltage. Actual Seebeck equation is EMF is proportional to delta T. Am I right? If you remove the proportionality, you will get sensitivity constant S into delta T. So this is approximate. This expression is approximate expression. But industrial expressions will use lengthy expressions. A into delta T plus B into delta T square plus C into delta T cube, so on so forth. Yes or no? Yes or no? All of you are understanding? Yeah, thermocouple equations are lengthy polynomial expressions. So these all are called polynomial expressions. Polynomial, sorry, some mistakes here. Polynomial expressions. So whether it is mathematics or my subject or any subject, if y is equal to ax plus bx square plus cx cube so on and so forth, then what is sensitivity? The sensitivity is nothing but change in output by change in input. Yes or not? Change in output to change in input. So if you express that in mathematics, that can be taken as dy by dx now. So if you take the sensitivity expression now, so what is the dy by dx here? That will become a plus bx square means 2bx, cx cube means 3cx square or not. The same way, in our problem what he asked, to check this problem, the EMF E is given by mathematics expression. Let me write the expression once again here. So what is the expression he has given? EMF is equal to 38.74 theta. Actually here I cannot erase, otherwise I could be doing here only. So EMF is equal to, let me write once again, please tell me that equation, 38.74 theta plus 3.3 into 10 power minus 2 theta square. 3.3 into 10 power minus 2 theta square plus 2.07 into 10 power minus 4 plus 2.07 into 10 power minus 4 theta cube minus 2.2 into 10 power minus 6 minus 2.2 into 10 power minus 6 theta power 4. Am I right? Minus 2.2 10 power minus 6 theta power 4. Yeah. Now what is the expression? Differentiate. Very good, Sushmita. We have to differentiate with respect to theta. So dE by theta. Very simple question. Very conceptual question. So if you simplify, that is 38.74 plus theta square means 2 theta. That will become 6.6 into 10 power minus 2 theta plus theta cube means 3 theta square. 3 comes here, 6.21 into 10 power minus 4 theta square minus theta power 4 means 4 theta cube. That becomes 8.8 into 10 power minus 6 theta cube. So theta means actually delta t. Yes or not? Theta means delta t. Delta t is the TH minus TC. If you do the cold junction compensation, TC is equal to 0. Sai Pavan following. TH is equal to hot junction temperature. In the problem, hot junction temperature is given 100 degrees Celsius. Shruti following? Yeah. Now if I take dE by d theta, it will be very simple to understand. That will become 38.74 plus into 100, then 10 power minus 2 gets cancelled, plus theta square 100 power 4, that becomes 6.21 minus 100 cube, this cancel 8.8. So you will get the answer as 42.75 microvolts per degree Celsius. Why? Because E is in microvolts, theta in degree Celsius. Following or not? Yes or not? See, option is, the options are not given. So all of you are enjoying the sessions. Monica, Kushal Jain, are you there? Yeah, thank you. So these are the different ways of asking the questions in temperature measurement. Dear students, not only for GATE exam, temperature measurement is essential for all the exams like BARC, DRDL. Very good question. This was asked in GATE 2015. Try to answer this question. This question is related to combination of thermocouples. The Seebeck coefficients in microvolts per degree Celsius. These are Seebeck coefficients. In microvolts per degree Celsius. For copper, constantan and iron with respect to platinum are given. That means sensitivity. Seebeck means sensitivity. So copper to platinum is given as how much? 1.9 microvolts per degree Celsius. Next, constantan to platinum is given as how much? Minus 38.3 microvolts per degree Celsius. Next, iron to platinum is given as plus 13.3 microvolts per degree Celsius. he has given Sushmita, he has given in kelvins, he has given not in kelvins, he has given theta in degree Celsius na Sushmita. Sushmita, that was given in degree Celsius na. Check the question. In the question it was given in degree Celsius na Sushmita. Yes or not? Yeah, that's the point. Understood? Yeah. Check the question. In the questions, yeah, you are asking here. Here also he has given degree Celsius. Don't confuse. Got it? Here also he has given degree Celsius. Okay. So sensitivity of copper to platinum is given. Sensitivity of constant to platinum is given. Sensitivity of iron to platinum is given. Got it or not? But if the question, if you check, in the question he is asking iron to copper na EMF, you see the plus terminal, the plus is here, the minus is here. That means he is asking between iron and copper. So he is asking EMF of iron to copper. EMF of iron to copper, can I write like this? EMF of iron to constant and law of intermediate EMFs plus constant to copper, can I write or not? So if you check iron to constant is at 15 degrees Celsius. So that means it is 15 degrees Celsius difference. Cold junction compensation we have to assume 0. So it is 15 degrees Celsius. Constant to copper is at 50 degrees Celsius. And if you are following this point, yeah, I will take that iron to copper. So if you take iron to copper can be taken as iron to constant plus copper to constant. Iron to constant is, so iron to constant, how to write? See here, iron to constant, all of you are able to see this picture. Iron to constant 15 degrees Celsius, constant to copper 50 degrees Celsius. So iron to constant, how to write? That can be written as sensitivity of iron to constant into 15 minus 0 plus, got it? Sensitivity of copper to constant into 50 minus 0. Now the point is sensitivity of iron to constant. How to find out the sensitivity of iron to constant? So sensitivity of iron to constant can be written as sensitivity of iron to platinum minus sensitivity of constant to platinum. Yes or not? So sensitivity of iron to platinum is how much? In the question he has given, iron to platinum is 13.3. Constant to platinum is minus 38.3. So iron to platinum 13.3 minus of, this is minus 38.3. So it will become 13.3 plus 38.3. That will become how much here? 3 plus 3, 6, 3, 8, 11, 1, 4, 3, 3, 4, 51.6. Correct enough? So it will become 51.6 microvolt per degree Celsius. Next what we want? Next we want copper to constant. So copper to constant, I can write it as sensitivity of copper to constant. And how can I write? That can be written as copper to platinum minus constant to platinum. Na? Pair sensitivity will be equal to subtraction of individual sensitivities. So copper to platinum he has given 1.9, constant to constant. I think somewhere you had a mistake. Check it. Yeah, copper to constant. Yes, constant into platinum. Correct. Copper to platinum is how much? 1.9. Constant to platinum is how much? Minus 38.3. 1.9 minus constant into platinum. Constant to platinum minus 38.3. So that will become 1.9 plus 38.3. Am I right? So that will be coming as 312. .40 microvolts per degree Celsius. Sorry, actually we want constant into copper. No? We want constant into copper. That is a mistake we are doing. So please make a correction. We want constant into copper. Yes or not? See, we want constant into copper now here. Iron to constant and constant into copper. So constant into copper kya hoga? Constant into copper we want. That is a mistake we have done. Constant into copper. Constant into copper can be written as constant into platinum minus copper to platinum. Okay, na? So constant into platinum is how much? Constant into platinum. Constant into platinum minus 38.3, copper to platinum 1.9. Minus 38.3. Constant to platinum and copper to platinum 1.9. Yes, 1. So 1.9. So that will become minus. Same. 40 point minus 40.2 microvolts per degree Celsius. Now we can write, yes, thank you, minus 40. That is a mistake we have done. Directly we can take actually copper to constant is plus 40 means constant to copper is minus 40. So directly I can write now EMF of iron to copper I want. Okay, na? So if you substitute that values here, I can get the answer. So this is how much we got. Sensitivity of iron. See, this is the problem with the slides. I have to rotate and see. So iron to constant we got as how much? 51.6. Yes, na Sushmita? So this is 51.6 microvolts per degree Celsius into 15 degrees Celsius, and this is minus 40.2 microvolts per degree Celsius into 50 degrees Celsius. So Celsius cancel. We will get the answer as some minus microvolts. I think you will get around. You can check the watt. You can check the answer. I think it will be coming as 1.632 something. You can check it. Okay. But the question, if you see carefully, he's asking in millivolts. Can anybody check this answer? Can anybody check this? I don't have the calci. Please check it. 1.632 milli or not? Check it. Milli or not? Sushmita, can you check it? Check this answer. Product take off 51.6 into 15 and 40.2 into 50. How much you are getting? I think you'll get a 1632 microvolts. Ashwin, yeah, I think you will get a minus 1632 microvolts, I think. Then I think we'll get minus 1.632. Yeah, but the question asked is in magnitude. That is important point here. Question asked is in magnitude. That is the most important point. That is a mistake people will do. He asked the magnitude in millivolts only. Very good, very good. So that will be minus 1.632 millivolts now. Answer is coming. Yes, minus 1.632 millivolts now. How much, Sushmita? How much? Minus 1.632 millivolts now. Yes. So the answer is minus 1.632 millivolts. But the question asked is in magnitude. Question asked is magnitude. Remember that point. Question asked is magnitude is also. So magnitude will be 1.632 millivolts. Understood or not, Sushmita? Why? Because it's a fill in the blank question nahi hai. It is the fill in the blank question hai. Multiple choice question nahi hai. So that's why if you give minus 1.632 millivolts, it is wrong. You have to give plus 1.632 millivolts. That is a correct. I hope you followed what I mean. Am I right or not? Chalo. Next we'll go for another analog question. So very good questions are there. Now how to solve this question? In the circuit below, the op-amp is ideal. That is the most important point. So this op-amp is ideal. And the sensor is an RTD. So this is RTD, resistance temperature detector, whose resistance is given as 1000 into 1 plus 0.004 theta ohms, where theta is temperature in degrees Celsius. The output sensitivity in millivolts per degree Celsius is asking. So how to do this problem? So first of all, is asking per degree Celsius. That means this is theta is 1 degree Celsius. R0 is 1000. That means theta is equal to 1 degree Celsius. Then what is the V0 in millivolts? V0 in millivolts. That is the way now we have to do the problem. So when theta is equal to 1 degree Celsius, RTD resistance क्या होता है? 1000 into 1 plus 0.004 na. So that is 1000 into 1 plus 0.004. That will become 1004 na. Yes or not? That will become 1004 ohms or not? Yeah. So this is now 1004. Now how to find out the V0? So dear students, this question is related to analog. So if you see the current direction, this is a current. The current gets split into two parts. That is I1 and I2. The current comes up to this. Ideal op-amp current cannot enter. So these two resistors are in series. Romario, are you there? Analog is most important. So if you check this current passes here. So these two resistors are in series. Now you can take the voltage division at 10. So what is the voltage division at this particular point? That will be 10k by this 10k plus 10k, 20k into 5 ohms, 5 volts. That becomes minus 5 volts. So that becomes minus 2.5 volts. So this is a minus 2.5. Am I right or not? So if this is minus 2.5, this is also minus 2.5. Now with respect to this minus 2.5, I can apply the node analysis. Minus 2.5 minus of minus 5. Minus 2.5 minus V0 by 1004. That means minus 2.5 minus of minus 5. That will become plus 5 by 1000 plus minus 2.5 minus of 1004. Sorry. V0 minus 2.5 minus V0 by 1004 to 0. So if you simplify, you are going to get V0 as 10 millivolts. That means the answer is 10 millivolts per degree Celsius. Have you got it? See, one more unlock question, let us see here. This is one more unlock question. This is also op amp is ideal. So, yes. Minus, it will not be minus, it will be 10 plus 10. Kumari, I think plus 10. Next question, if you see this question, now how to solve this problem? The junction semiconductor temperature sensor shown in the figure is used to measure. So current here cannot enter. The current cannot here. Current is equal to 0 in this direction. So whatever the current developed, the current will go like this only. So current is passing like this only. Okay, now current is passing like this only. So how to do this problem? The junction semiconductor temperature sensor. The junction semiconductor temperature sensor shown in the figure is used to measure the temperature of hot air. Temperature of hot air. So this hot air is touching. And the current is given by expression I is equal to T microamperes. That means according to the temperature, current is coming. So temperature should be taken in Kelvin scale. Kumari, here Kelvin. Here temperature scale is Kelvin. Here Kelvin. Okay, na? So what is given? Where takes the temperature. Assuming the op amp to be ideal, the temperature of the hot air in degrees Celsius is approximately dash. So here how to do? So first of all, this V0 he has given 2.1. So we can start the journey from here. So this is 2.1 means this is a current direction. So this is the current direction. So if you see the current direction, so what is the current? You can find out the voltage here. Why? Because these two are in series. So the voltage at 1K is equal to 1 kilo ohm by 1 plus 2, 3 kilo ohms into 2.1. That will become 0.7. So this is 0.7. Means this is also 0.7. Means this is also 0.7. This is also 0.7. Am I right or not? Now what is I? I is equal to 0.7 by 2K. Why? Because this is ground. So that will become what? 7 by 20. That becomes 7 by 20. That means 3.35. 0.35. It will go to the top. 0.35 to 10 per minute. I think 350 microamperes. So if I substitute that here, 350 microamperes is equal to T into microamperes. Microamperes, micro cancel. So T is equal to 350 Kelvin. 350 Kelvin. Yes or not? But question asked, Jan se dekho, he asked the question in degree Celsius. Kumari, are you there? Yes, in degree Celsius. Question asked in degree Celsius. So answer must answer in degree Celsius. Okay, na? So what is the answer? This will be how much? 77 degrees Celsius. And for understanding, here students, these are all the questions. Kumari, are you following Sushmita Kumari? Sushmita Kumari following or not? Now let us go for the last question of this session. This is another session. This was asked in GATE 2017. That means questions are combination of analog plus transducers. So without analog we cannot skip. Yeah. A resistance temperature detector RTD is connected in a circuit as shown in the figure. Assume the op amp to be ideal. Op amp is ideal. if V naught is equal to 2 volts, then the value of X is dash. How to solve this question? V naught is equal to 2 volts. Same, this is 0. Virtual ground concept, this is 0. Then this is 0. So with respect to this, we can apply the node analysis. 0 minus 12 by R into 1 plus X plus 0 minus of minus 12 by R plus 0 minus V naught by R. Yes or not? So 0 minus 12 by R into 1 plus X plus 0 minus of minus 12 by R plus 0 minus V naught 2 by R is equal to 0. R gets cancelled. If you simplify X, I think you get 0.2. Sushmita, followed or not? Check it. R gets cancelled. Minus 12 by 1 plus X plus 12 minus 2 minus 10 plus 12 minus 2 plus 10 plus 10, it goes there, minus 10, minus plus gets cancelled. Anywhere mistake? Check it. Correct only na? 0.2, right. 0.2 is the correct answer. Very good question or not, Sushmita? So these all are the different questions, dear students. So my dear students, I am ending the session. I hope all of you enjoyed the sessions. So I hope you got some clarity. Clarity of importance of sensors. Clarity on importance of sensors. Yes or no? So dear students, on Unacademy, I am discussing all these subjects on Plus course. If anybody is planning for a subscription, I suggest you please go. Instrumentation is fully established. On Unacademy, instrumentation, yeah, I will plan a session, is fully established. So that I can assure you. I can assure you on 3 subjects: sensors and optical and process control. So if anybody is planning for ESE questions also, that is a separate session, Sushmita. Sushmita, separate session. One more session we plan, ESE questions. So dear students, if anybody is planning for the subscription, everybody knows that what is the importance of online education now. Because of Corona, nobody is going, no opportunity to go for offline coaching. On Unacademy, comfortably you can stay at home and you can get the sessions free. Valuable sessions, most easy, most worthful sessions. Why? Because 27,000 for 24 months. That means monthly 1,000 rupees only you are paying. So which is more better than ACE Academy or Made Easy or any other institutes, any other offline coaching centers. Okay, dear students. So use this opportunity and enrich your knowledge. Okay, Sushmita, I'm logging off. If anybody is having any doubts, you can contact me. This is my contact number and this is my WhatsApp. This is my code, DSK10 code, my code. So please promote my code. So please refer to your friends. Refer to your friends also. This code. Okay. So thank you very much. I wish you all the best. We'll meet again with another session in the next classes. Okay, na? In the next classes. Thank you very much. Thank you. Namaste. Thank you, Sushma Kumar. Sudarshan, how are you, Sudarshan? Namaste, Sudarshan. Bye.